All right, so this is problem 6 on the practice with areas of triangles. Of course, everyone's problem was a little bit different, but the question that was asked by Gwen had these numbers. So you have 3 circles, radius 6.9, 11.1, and 9.5, all mutually tangent. So I drew those circles in here so that they just touch each other in those spots. The question is, what's the area bounded by them? So I think they're talking about the area that's using those triangles as, sorry, those circles as its boundary. So this region in here is what we're looking for, the area of. So what I think I'm going to do then is I'm going to, if I connect the centers of the circles together, actually, that this line right here is actually perpendicular to the circle, and its length 6.9 plus 11, so that would be 18. Likewise here, connecting this center to that center, the length would be 6.9 plus 9.5, or 16.4, and then these two centers connected together would have length 20.6. So that triangle, if I can find the area of that and then subtract the area of those 3 sectors, then I'd get the area that's in between here. Okay. So the first thing I need to do is find the area of that triangle. Now I could use Heron's formula or Hero's formula, depending on what book you read, to just use those side lengths. I'm opting not to do that. I'm going to use the law of cosines to find angle A. I need the angle anyway, because to find the angle of each sector, the area of each sector, I need to know the angle. So, so I'm going to find those angles anyway. I'm going to use the law of cosines to get the biggest angle here, A, so then I can use the law of sines to get the other two. Remember, the law of sines might get the biggest angle wrong, but the law of cosines won't. So I'll do that one first. So law of cosines here, 20.6 squared equals 16.4 squared plus 18 squared minus 2 times 16.4 times 18 times the cosine of A. So the cosine of A is this, and then you do the inverse cosine. And I wrote this as 73.4. When I checked my answer against WAMAP later, I'm not accurate to 4 decimal places because right here I rounded too soon. But anyway, I'm going to keep going with these computations because we're close enough for at least to explain how this works. You should carry a few more decimal places until the end, but I'm calling this 73.4. So then to find angle B, I'm using the law of sines, saying sine of B over 18 is the sine of A over 20.6. That's what I've got right here, but A is 73.4. I'm pretty sure that I used more decimal places on this calculation because it was already in my calculator, so I just figured out what B was. This is probably good, 4 decimal places. And then, of course, C is subtract 180 minus that one minus this one. So we've got that. This one, I'm pretty sure that I rounded the 73.4 in this calculation. So this is not good to 4 decimal places. But anyway, you got those angles. So now I'm going to do the area of the triangle as 1/2, I think of it as the base times the height, or 1/2 AB sine C, or I guess this is 1/2 BC sine A. I think of this as, if I take 16.4 times the sine of angle A, it's going to give me that altitude right there. 16.4 times the sine of angle A. And then if I do 1/2 the base times the height, I got the area of the triangle. So 1/2 the base, 1/2 times 18 times the height of 16.4 sine A, that's the area of the triangle. Unfortunately, when I did the calculation the first time, I didn't have the 1/2 out in front, and I got this 282, and the answer should be 141. So anyway, the area of that triangle is 141 point whatever. This is not quite right, because again, I'm using that 73.4, which is rounded. I didn't carry enough decimal places. Anyway, so now the areas of the sector are 1/2 the radius squared times the angle in radians. So I've got 1/2, so doing this one over here, 1/2 times 6.9 squared times that angle converted to radians is 30.495, whatever. Likewise, angle B, so using 9.5 as my radius, and the angle is 56.866 converted to radians. That's the area of that sector, and likewise angle C using 11.1 as the radius, and the angle of 49.73 converted to radians. So there's the three sectors. They add up to a total of 128.7 whatever, and when I do 141 minus 128, I get 12.697. Now when I looked up the answer on WAMAP, they wanted it as 12.70 something. I rounded here, which caused that to be off, but this is the idea, that this area in between here is the area of the triangle minus the area of the three sectors. So anyway, there you go.